All right, this is the last part of topic 1 that we need to go over, and it's on diluting solutions. So it says, it is often necessary to dilute a stock solution to obtain a desired concentration. There are also scenarios in which require water to be evaporated from a solution to make it more concentrated. In each case, the amount of solute is unchanged, but the amount of solvent increases or decreases. Because the number of moles of solvent remain constant, the following formula may be used to compare such solutions. So what that all means basically is that when we get a chemical from a science company, for instance, I'll give the example of hydrochloric acid, so HCl. What comes in from the science company is going to be something that's like 12 moles per liters. So that's a really, really high concentration, and maybe in a lab we only need 0.1 moles per liters. So in using this formula that we have here, we can actually calculate how much of that 12 moles per liter solution we need to make like a really small amount of 0.1 moles per liter. So every time I would create something for a lab or any science teacher, they would use this formula. So it's a really important formula. It's not just something that we're going to teach you now and forget about it. It's something that's kind of important moving on if you are ever in chemistry. So the formula is, it says the CF or CI/VI is equal to CF/VF. And what that means is it's the initial concentration with the initial volume is equal to the final concentration times the final volume. Okay? And maybe that doesn't make sense right at the moment, but it will make sense when we go do an example. So what I'm going to do is we're going to do this example out in A and B. So the example says you are given a 65 milliliters of a 0.759 moles per liter solution of sodium chloride. So just to recap you, our information or our formula is CI/VI is equal to CF/VF. All right. So they've given us the initial right here. So this right here is a volume. So that would be our volume initial. And our concentration initial is 0.759. All right. Then it says in A, it says calculate the final concentration of a solution if it is diluted to a final volume of 100 milliliters. So that is telling us right here that this is our final volume. So that'd be VF, volume final. All right, so how I'm gonna do this is I'm gonna move it over to the notes just so I can write. And I'll carry all the information over. So if we're looking at our formula, we got CI/VI is equal to CF/VF. I don't know. Whoa. Sorry. CI/VI is equal to CF/VF. I said VI, but I put VF. All right, so if we write down what's given to us, we got CI/VI, CF/VF. So we go back to this right here. Our CI and our VI are given to us in the formula, or in the question. Our VI is 65 milliliters. And our CI is 0.759. Make sure that you're putting in your units, because that's important. And then in A, it says our VF is 100 milliliters. So we've got our 100 milliliters for our VF. So the piece of information that we're missing here is our CF. So we can calculate for that. But something that's really important before we do that is that we need to have our volumes in liters. See how this says moles per liter? So we're going to have to change our milliliters into liters. Okay. So to do that, my rule of thumb is always to move the decimal 3 places to the left. So if we do that, the decimal would be here, 1, 2, 3. So by doing that, our liter amount would be 0.065 liters. And then if we do the same thing over here, 1, 2, 3, then our liter amount would be 0.100 liters. All right. So that's all the information we need. We've got 3 out of 4, so we can plug it in and solve for the missing piece. And our missing piece is CF. So we got CI VI is equal to CF VF. Plug in our information. CI is 0.759 multiplied by our VI, which is 0.065, is equal to our CF, which we don't know, and our VF, which we know as being 0.100. All right, so now we can solve. What we like to always do is move all the numbers to one side and the unknowns to the other, so we're going to get rid of this point. Oops. .100. So if it's multiplied, we do the opposite, which is divide, and we get rid of that. What we do to one side, we've got to do to the other. So balancing act. So we've got CF is equal to whatever the answer is to this. So if we calculate that out, which I'm going to do on my phone, 0.759 times 0.065 divided by 0.100, I get an answer of 0.49335. And so that would be our final concentration. Concentration is written in moles per liters, so that would be our answer. I would recommend that you write your answer into 2 decimal places, so we would just drop this. So the answer should be 0.49. Okay. So that is A. Let's do B. All right, so B says, how much water do you need to add to the original solution to obtain a solution with a concentration of 0.200 moles? So we're still starting out with the same VI-CI. We're just changing the final. So our final concentration in this question is going to be 0.200. All right? So our missing piece of information that we need is our VF. So let's go back to here. We're starting from scratch. So we got CI, VI. Those are going to be the same as the last question. I'm writing it in liters. And then we got CFs and VFs that are going to be new. They've given us our CF in this question as being 0.200. Just to show you where I got that from. So it says to obtain a solution with a concentration of this. So this is our final 0.200. So that's why I'm putting that there. And then our VF is what we don't know. All right. So now we can again plug this information into our formula to solve. So CI-VI is equal to CF-VF. Plug our pieces of information into the formula. So our CI, right there, times our VI. Is equal to our CF times our VF, which we don't know. All right, then we're going to solve. So again, moving our numbers to one side, keeping our unknowns on the other. That leaves us with VF is equal to whatever all this is. And we can plug that in our calculator. So 0.759 times 0.065 divided by 0.200 gives me an answer of 0.246675. And remember, I always like your answer to be rounded to 2 decimal places, so our VF should be equal to 0.25. How I got that, just to refresh you, we want to keep 2 decimal places, so we always need to look at the next one. If this next one is higher than a 5, then this number will go up, okay? If it's lower than a 5, then it would just stay the same as 0.24. So it's 0.246, we round that up to 0.25. All right, so that is how we do dilution formulas. You guys will have some questions in your topic 1 review. And if you have any questions, let me know, but refer back to this for your examples.